Okay, so some notes about Chapter 6. We started it last week, but we'll continue it this week, and we'll continue it online as well. So there are some videos on, if you go to Blackboard and you go to the videos link. And then if you just go in the upper left, there's this playlist, and then you can find the videos for Chapter 6. So they're for sections 6, 13, 14, 15, and 16. So sorry, they're not in order on the playlist. I'm not good at enough at YouTube. I don't know how to do that. So, oh, cool. Oh, is that me? Oh God. Okay. So, it's funny. Anyway, yeah, here are the sections that are online, and so we won't do them in class, but the kind of plan is to just have everyone watch the videos. So 6, 13, 14, 15. For now, if you go into Blackboard and go into the in-class link on the left, I thought that was cool last time with the kind of interactive demos, and so I tried to get for the rest of Chapter 6. Well, the kind of middle portion, stuff we didn't do last time, but that's not in the video. Section 6.5 is about pass by reference. And the two ways that data can be passed are by reference and by value. So did anyone read the book, and do you remember what's the difference between those? Yeah, sure. What's the difference between pass by reference and pass by value? Remember? So yeah, pass by reference. And pass by value are two ways to pass around data. Um, and the idea is if you have a variable in memory, you can either pass it directly into a function, meaning that the function has access to that variable. It knows its address in memory and can change that variable directly. Yeah, pass by value. What's pass by value? So, sorry? Yeah. Uh-huh. Yeah, the 7 is what goes, exactly. Uh-huh. So does the original argument go into a function if it's passed by value? No, only a copy of it. So like if the value is 7, it's only the copy of that 7 that goes. So it's only the value that goes in, but it's not the actual variable itself. So pass by value, copy is made, meaning that a function can't have any effect on the original because it just received a copy of the argument. And pass by reference, on the other hand, the memory address is that memory. here's an example program where we'll see how we can get ourselves into trouble sometimes if we choose one over the other. So the way that we've been doing things, which one do you think it is? Is it passed by value, passed by reference? We've been passing things by reference? Maybe. We've actually been passing them by value. We've actually been passing them by value, and there's a special kind of additional thing that we would have to do to pass a variable by reference. Yeah, yeah. And let's see how that affects the code that we've been writing. So here's a program that has a function called increment, and it's got the main function. And it looks like we set any x to anything we want. And let's try to predict the output. So if x, what do we want to start it as? 1? Or should we change it? 7? Okay, cool. Start x as 7. That's great. Okay, awesome. And can anyone predict the output of this program? Not going to change it? Okay, vote for not going to change it. Does anyone disagree with that? Not doing anything to it? Yeah, not. Okay, cool. So maybe x will become 8 at the end. And then we have some votes that say x will remain 7. Yes, Okay. So line 14, yeah, it's going to pass x into the increment function, but it's being passed by value. So it's really passing a copy of x to the increment function. Yeah, exactly, Oh, I'm sorry, before the call x is 7, yeah. After the call, actually x stays 7 because the function never had access to x. It only had access to the original, or to a copy of x. Yeah, so the original is not affected. Yeah. Oh, good call. Yeah, right. Can you tell us a little more? Okay, cool. Awesome. Okay, cool. Yeah, and then if we change line 14 to say x equals increment x. Yeah, okay, cool. Yeah, that's a nice workaround. Cool. That's good. We'll see one other line right in the middle. There's a line that when increment runs is printed out. So what'll that line say? We know it'll say before the call x is 7, and then there's some other line. What'll the next line say? Cool. And inside the function is 8. Awesome. Cool. Exactly. Because that copy of x gets like pasted into n. Cool. Okay. Awesome. So yes, n plus plus will send n from 7 to 8. And so we'll see n inside the function is 8. But then remember, since we passed x by value to the increment function in line 14, x is not affected. That original is not affected. So after the call in line 15, we'll see x is, what will we see? 7 or 8? 7. Yeah. Okay, and let's run through the animation. So the program starts the execution from the main function, and line 12 assigns 7 into x. We've got the output from line 13 before the call x is 7. And what will be x after invoking increment x? Everyone agree? 7? Yeah, good call. 7. Yeah, nice. Good. Because remember, increment has no effect on the original. The statement invokes the increment function. Invoke just means to call a function. We've been calling it call, but it's same as invoke. So then the 7 gets passed to n. So that's the Yeah, so that's when 7 is stored to n and then is incremented to 8 and printed out the value, oops, sorry, n inside the function is 8. But then after the call, x, you know, x was always 7. Yeah, cool. So any follow-ups about that? And here's just then just our the live example, so the one where you can like put in the code. And so this was our increment function header, so I know it was just above, so it doesn't make a lot of sense to spend a lot of time filling it in. Here's our increment function, took in an int n, and here we changed x to 7. And if we run it, yeah, we see before the call x is 7. Call x is 7. Yep. Yeah. Yeah, it's cool, right? Yeah. Yeah. So who can think of a time when it would be a good idea to pass by value and not by reference? Yeah, okay, cool. When you want to retain the original values. Cool. Yeah, exactly. Cool. So when you don't want something to be allowed to be changed, right? Yeah. Oh, hey, come on in. No problem. So here's where things can start to go a little south when we try to pass by value. Okay. So here's a program that has a swap function. And it takes in 2 ints, and its purpose is to whatever was in n1 goes into n2, and whatever was in n2 goes into n1. We can start off the variables as anything. Should we leave them as 1 and 2, or should we change them? Change them? Okay, cool. What should we change them to? 3 and 8? Okay, cool. Okay, num1 is 3, num2 is 8. So who can predict the output now? Before invoking the swap function, num1 is, and num2 is. 3 and 8, totally awesome. And then invoke the swap function, passing in num1 and num2. Are they passed to the swap function by value or by reference? By value, awesome. So it's really a copy of the 3 and 8 that's made, and then that goes into n1 and n2 respectively. So inside the swap function, before swapping, n1 is what? 3, yeah, and 2 is 8, yeah, And then the swap, these lines, 12, 13, and 14, it's kind of like a chain. See how n1 is on the right in the first line and the left in the second line, and then n2 is on the right in the second line and on the left in the third line, and temp's on the right in the third line and on the left in the first line. So what that has the effect of is carving out a variable temp and just temporarily storing n1 to it. Then once n2 gets stored to n1, well, then they'll both have the same value. It'll be whatever n2 was. And we might think, well, we had to put n1 in n2. Well, that's fine because we had stored n1 to temp. So now we'll just put whatever temp was into n2. Yeah. And the animation will show that too visually, so that's always nice. Okay. So after swapping, n1 is what? 8, yeah, cool. And n2 is 3, yeah, cool. Good question. Yeah, so swapping, do you mean the swapping? What is that useful for? Okay, yeah, sure. Yeah, anyone have any? Yeah, Oh, that's a cool idea. Yeah, awesome. A lot of sort algorithms use swapping. Yeah, to organize it. Yeah, exactly. Uh-huh. So, uh-huh. Yeah, a lot of sort functions use swapping. Yeah. And We still have some more output. After invoking the swap function, num1 is, what do you think, 3 or 8? Okay, vote for 3, vote for 8. Yeah. Or num1 is. Yeah. Still 3. Yeah, okay, awesome. Uh-huh. Yeah, how come? Because I thought we passed it into the swap function. I thought it swapped it. Cool. Okay, awesome. So we passed by value. So it was just a copy of the 3 and 8 that was sent. So they keep their stored value, num1 and num2. Yeah. Awesome. Uh-huh. Yeah, okay. So then the last thing we'll see is after invoking the swap function, num1 is 3 and num2 is 8. Okay, and here's the animation. So the program starts the execution from the main function. The statement assigns 3 into num1. And the next statement assigns 8 to num2. The output, it looks like what we said is right. Yeah, from before. And what will the value of num1 and num2 be after invoking swap 3, comma 8? What did we say? Uh-huh. Yeah, 3, uh-huh. And 8. Yeah, exactly, uh-huh. The values weren't swapped. And so, you know, it kind of defeats the purpose, right? Okay. So what would a solution be where we can actually swap num1 and num2? Yeah, or yeah. Oh, no problem. Yeah. So it sounds like can we swap them with pass by value, or do we have to send in the originals? Yeah, let's send in the originals. Yeah, awesome. Uh-huh. Cool. Oh, and here's just the live form of that. So I think looks like it's all filled in there. So we can run it and see again the output. But it looks like the same thing we said. Num1 was 1 and num2 was 2. And then n1 and n2 were 1 and 2 before swapping, and then 2 and 1 after swapping. Might have missed a line of output there. Okay, but anyway, but yeah, they do swap in the function. N1 and N2 do, but they're just copies of the originals. So yeah, num1 and num2 never swapped. So they're still 1 and 2. Okay. So we can write a function to swap two variables. The function can do that by passing in a reference variable instead of just passing the variables by value. We said earlier that the reference variables, when we pass by reference, they send in the memory address of that variable to the function. And so the original can be changed. To declare a reference variable, place an ampersand in front of the variable or after the data type for the variable. So here's some code that declares a variable R as a reference variable. And do you see it's the exact same as just declaring a variable R, but this one it has the ampersand before the variable name. You could also put the ampersand right after the data type, or even with two spaces, one to its left and one to its right. So actually we have three equivalent ways of declaring a reference variable. So now let's kind of go back to the beginning, and let's see how changing a variable to a reference variable can affect things. So here you might notice R is a reference variable, and it's going to get the value of count, which is 1. So who can predict the output from this program? Okay, count is 1, R is 1. Okay, cool. From lines 8 and 9. Cool, okay, awesome. And then R gets incremented by 1 in line 11. So we'll see, what will we see? count is 1, awesome. R is 2, yeah, awesome. Cool. And then in line 15, looks like count is going to get reassigned to be 10. So count is 10, and here's the trick, R is 10. Okay, cool. Why is R 10? Because I thought it was 2 and all we did was change count. Nice. Awesome, cool. I couldn't have said it better myself. So whatever happens to either of them, we'll change both of them because they're both pointing to the same place in memory. Awesome, cool. Oh, so we should do the animation. Program starts from the main function. And assigns 1 to count. And then R, yeah, exactly, points to the same place as count does, which is storing a 1 right now. So when we print out count and R, they were both 1. And then R got incremented by 1. Oh, I'm sorry, this is, we said the wrong thing. Didn't we? Count is 2, yeah. Oh, value representing count. R plus plus, count is count. R is 1, count is 2. Oh, did we say the right thing? Oh, yeah, okay, cool, awesome, yeah, okay, nice. Yeah, probably a better way to draw this would be, yeah, yeah, like that. Okay, cool, yeah, okay, okay, yeah, that's good, okay. And then, R is, oh, count is 1, R is 1, count is 2, R is 2. Yeah, we did, okay, I'm sorry, why am I getting so confused? So, uh, yeah, they're referencing the same thing and that thing changed to 2. And then once that thing changes to 10, just like we said, yeah, count is 10. And then let's make sure R is 10. Yeah, cool. Sorry, I got really confused in the middle there. So any questions though about that? Okay, cool. Sorry, that's embarrassing, but okay. So we can run the program down below in this in this compiler here. And we see the results that we just saw. And let me ask a follow-up question. What if we changed R not to be a reference variable anymore? So I'll just do the simple thing of deleting this ampersand in line 7. Then how would that change the results? Okay, so vote for R it would be the same the whole entire way through, so it would be 1 the whole time? Okay, cool. Vote for it will get incremented once. So in line 11. Yeah. Any other votes? Okay, cool, awesome. So so we'll see, so count is 1, R is 1, and then we'll see count is 1, R is 2, and then we'll see count is, yeah, down here, count is 10, yeah, and R is, yeah, 10 or 2. Yeah, well, they're not pointing at the same place. R just had a copy of count. So now, yeah, even though count got changed to 10, R stays as 2. Yeah. Okay, cool. So we see down here what would happen if we had deleted that, right? That that part where we made R a reference variable. and here's the, oh, this is what I tried to do on the board. So, okay. Um, when they're both pointing at the same place, then whatever that place, you know, is or changes to, they'll both have that value. And then building up now to our second example, remember our swapping example. Oh, actually, no, still not building up. Going back to the very first example, here now if we pass n by reference, how will that change things? So now we've got two functions and we're passing from the main function to the increment function, but not by value anymore. Well, that changed things. Cool, okay, so before the call x is 1, and then increment x, we'll see, what would we see from that line? And inside the function is 2. Okay, cool, awesome. And then after the call x is 2. Yeah, awesome. Cool. And why 2 and not 1? Exactly. Cool. Cool. So we said if we pass by reference, we send in the memory address of the original, and therefore the original can be affected. Okay, so let's go ahead and go through the animation. Assigning 1 to x. Displaying the value when the main function is just starting. Well, you know, second thing. And then the value of x after invoking increment x, we said is going to be 2. Cool. Yeah, sure. Sorry? Oh, actually, x is, the memory address of x is being assigned to n. Yeah, it is. But the only difference is is passing the parameter by reference. But that means that then instead of making a copy of the one like before and sending that into increment, we'll just send in the address of the variable x, and then increment will take whatever's at that address, and it'll add like another. Um, um, it'll also call it n. Yeah, so then n and x will be pointing at the same place in memory. Yeah. Oh, good question. It's just nothing. Yeah, it's being declared here as a reference variable inside the parameter list, and yeah, it's just it's not pointing to anything. Yeah, yeah. So once the function gets called, that's when either the memory address, if it accepts the argument by reference, will take in the address, or if it's passed by value, just a copy will be sent into n. Yeah. Yeah. Oh. Yeah. Yeah. Cool. Yeah. So in terms of space complexity, yeah. That sounds like generally that would be true. Yeah. Yeah. If you can just start changing stuff directly, it's better than having copies and returning copies. Yeah. Awesome. Yeah. Yeah. That's a really cool point. So passing by reference, yeah, saves some memory compared to passing by value. Maybe you could even compare the last or those programs with n, and you'll see, yeah, there was that one memory space carved out um, in the last one, and both x and n were pointing to it. But in the first one, there were two memory spaces, yeah, one for x and one for n. N was just the copy. but they weren't the same. They were pointing to the same thing. Awesome. Okay, nice. Oh, thanks for that. And here was our pass by reference. So just to remind ourselves, we pass by reference not like this, but how? Yeah, aha, exactly. Aha and ampersand. Good call. Oh, we can run this. Okay, so it looks like x was 1, but when it was passed by reference, it got incremented. Well, yeah, n got incremented to 2, but also x got incremented to 2 because this time they were pointing to the exact same. So last example here, our swap function. Now, if we pass in n1 and n2 by reference, then when we call swap and pass in num1 and num2 as arguments, the addresses of num1 and num2 will be sent to the swap function, and therefore they can be modified directly. And so, yeah, we can swap stuff, and it'll actually have an effect on num1 and num2 instead of just copies of num1 and num2 when we pass by value. So should we change them to 3 and 8 again? Okay, cool. That's a good experiment. Okay, 3 and 8. Good. Okay, cool. And do we have to add anything? Or are we ready to go? Is this all set to pass by reference? All set? Okay, cool. Awesome. Start the animation. And 3 gets assigned into num1. It gets assigned into num2. Before calling the function, num1 is 3 and num2 is 8. And after invoking swap 3, 8, what are the values of num1 and num2 going to be? 8 and 3. Awesome. Good call. Yeah, cool. Nice. Swap functions invoked by passing the references of num1 and num2. Is that num1 and num2 to n1 and n2? n1 and n2 are the same. Oh, sorry, n1 and num1 are the same. n2 and num2 are the same. Cool. And I like if you were following Dong's point from earlier, yeah, here's the there's only 2 spaces in memory that are needed instead of 4, like before. Before swapping, n1 is 3 and n2 is 8. And then we've got this temp variable where n1 goes, so the 3 actually does get copied to temp, so that's just it's not a reference variable. It's just making a copy of n1, but that's good. We don't want to. We want this. We want just a copy, right? Otherwise, when we screw up, we would screw up some stuff. So we'll make a copy of n1 anyway. Yeah. Copy of n1, and then assign the value of n2 to n1. So now they're both 8. And then let's assign the value of temp to n2. Yeah, So now n2 has the 3 from before. Yeah, okay. And now they've been swapped, and since we passed by reference, we know that into the function n1 is 3 and n2 is 8. But even after the function, since we had access to the originals, n1 is going to be 3 and totally missed the last one. Anyway, yeah, better restart. We said after invoking it, 8 and 3, we said, right? here we go. After swapping, n1 is 8 and n2 is 3. Okay, so is this making sense, the difference between pass by value, pass by reference? Okay, cool, awesome. That's super important concept, and so I'm glad, that's good. And we could fill in the rest of the live example. Invoke the swap function to attempt to swap two variables. Who can remind us how do we do that without looking? Yeah, nice. Swap. Yeah, nice. Num1 and num2. Like that. Oh, oh. Um. Well, yeah, you can shift over stuff to the right. Like if you had 3, 4, 5, then you could make it 4, 5, 3. Yeah, that could be a cool like extra credit problem. Yeah, taking 3 variables and like shift them. Yeah, cool. And it looks like once we run this num1, which was 1, and num2, which was 2, after the function now have been swapped. So that's good. So any other questions or like experiments that we want to try, anything before we move on?